With all lines welded back in place, you can evacuate and charge the system. Today, all Electrolux refrigerators use R134A refrigerant. While some hybrid refrigerants have been developed, they are not compatible with 134A. Because of that, Electrolux does not condone the use of hybrids in any situation. Charging with a hybrid is setting a booby trap for the next servicer to work on that product, possibly years down the road, because unless the compressor has been marked with the type of hybrid and oil used, the next guy to evacuate the system will contaminate all of his equipment, along with any 134A he has already recovered from other products. While sweep charging is commonly used by servicers, Electrolux does not recommend or condone this practice on 134A systems due to its inconsistent level of success. The problem is that on a highly contaminated system, especially one with a compressor replacement, sweep charging the system pushes contaminants through the compressor, contaminating the oil in the compressor, causing eventual failure or reduced efficiency and the need for a repeat service call. It's critical that if your pump is used on systems with R12 and systems with 134A, you ensure that any mineral oil that could be in the pump does not get into the sealed system. Even the smallest amount of mineral oil, when mixed with ester oil, will foam up and cause a restriction in the dryer filter and capillary tube. Electrolux specifies the use of 4 ports when charging a sealed system. The 4th port in the system enables you to isolate the pump, ensuring that mineral oil in the pump never gets into the sealed system. If you're using a 3-port manifold, then add a T-connector to the charging port so you can isolate the vacuum pump from the charging device. Connect the high side at the dryer and the low side at the compressor's process line. Connect from the vacuum pump to the pump port on the manifold and connect from the charging cylinder to the charge port on the manifold. If you're using a 3-port manifold, a T-connection with shutoffs on both sides should be used here. With all valves closed, including the dial-a-charge valve, start the vacuum pump. Open first the valve connected to the vacuum pump. Then open the low side valve. Open it slowly to prevent drawing any ester oil out of the compressor. Then open the remaining valves so that you draw a vacuum on all of the hoses as well as the sealed system. You must draw a vacuum of 30 inches for 30 minutes to ensure your system is properly vacuumed out. Or if you have a micron gauge, simply pull the system down to 500 microns or less. This is a good time to ready your charge. First, determine how much 134A is needed for this unit. That info is on the model number and serial plate. If you're using a dial-a-charge, heat it up to around 30 psi higher than the ambient temperature. Then set the dial-a-charge to approximately 30 degrees higher than ambient temperature. Set the adjustable indicator based on the charge required by the system. This unit has 13 ounces in it. The charge requires 6 ounces of refrigerant, so we set our indicator at 7 ounces. If you're using an electronic scale, make sure it's calibrated according to the manufacturer's recommendations, and be extremely careful not to touch the tank or its main valve while dumping the charge. While pumping the system down, if your pump has a bubble window, check it occasionally. You may see the oil start to foam and bubble a little. That foaming will prevent you from pulling a deep vacuum. If that happens, reduce the flow and the foaming should disappear. The most critical step in this procedure occurs when you reach the targeted vacuum. You must close the pump valve before turning off the pump. Otherwise, you will pull contaminants and mineral oil back into the system from the pump. After turning off the pump, close both the high and low side manifold valves. Let the system sit for at least 10 minutes, verifying that it can hold this vacuum. Once you're sure you've got no leaks, start dumping the charge. Begin by opening only the high side valve and dump the measured charge through the high side. Once the charge is in, first shut off the charging device, then the charging valve and the high side valve. Some of the charge will be left in the charging hose, the high side hose, and the manifold. You'll fix that in a minute. Now turn on the compressor. As the condenser warms up, the high side gauge should start climbing and the low side should drop. If they don't, you may have accidentally welded a line shut. Once you've established the system is working and has no blockages, pinch off the high side line of the dryer. With the pinch-off tool in place and with the compressor still running, slowly open both the high side and the low side valves and the charging port valve. This will allow any refrigerant lying in the high side, low side, and charging hose to be pulled into the system through the low side, reducing the chance of short charging the system. This system of charging ensures that all of the refrigerant leaving your charging device will end up in the sealed system, but it only works if you keep the low side valve closed while dumping the charge. Now you can close the low and high side valves and turn off the refrigerator. Remove the high side hose, and with the pinch-off tool in place, and with the compressor turned off to reduce pressure, weld the end of the process tube shut. Only remove the pinch-off tool when you have a good weld. Now turn the compressor back on until the low side gauge is just about down to 0 and pinch off the low side process tube. Again, turn off the compressor to make welding easier. Remove the hose and weld the process tube shut. You should now have a properly charged sealed system.